Hello everyone, I'm Shivai and today I'm going to be talking about the MediaPipe Selfie Segmentation solution that was just announced 2 days back by the MediaPipe team at Google. Now, before talking about what exactly is the MediaPipe Selfie Segmentation solution and how does it work, and also showing a demo that has been provided by the MediaPipe team, first I would like to just talk a little about what exactly is MediaPipe, what does it do. Now, MediaPipe is a solution that has been used in Google for a long time. It was only released to the public only in 2019, and before that it was sort of a black box for the general public. But within Google it is being used to power a lot of different services, including inside of YouTube streaming as well. And it is only recently that MediaPipe was also it got support of TensorFlow. So inside, like, MediaPipe is being powered by TensorFlow Lite, and it was only recently that in 2019, when MediaPipe was launched for the public, that it got also support for machine learning. And today it's being used by a lot of different services, and it's very popular for running a lot of different machine learning solutions on low power devices. So essentially, it provides live ML anywhere. So it offers a lot of different open source and cross-platform machine learning solutions for live and streaming media. So a lot of different video-based, audio-visual-based solutions, which we'll be talking about in detail in a bit. And it's like having cross-platform support, so it can be run on desktop, on Android, iOS, and also on web, with having support for JavaScript. Now, if we talk about some of the popular ML solution that it provides, it includes human pose detection and tracking, which looks at 33 different landmarks covering your entire body, and it can do a lot of different amazing solutions. For example, you can create your own personal AI training, like buddy, or let's say you can create like a physiotherapist using this, and you can track your entire body with the help of this. There is also a solution in TensorFlow JS that is the PoseNet model, and it's based similarly to that. And then we have face mesh that has almost 468 different landmarks on your face that cover your entire face, and you can think of a lot of different amazing solutions that can be built using face mesh. Then we have the hand tracking that uses landmarks to track your entire hand. Then we also have the holistic model that tracks all the different three solutions that we have spoken about till now. That includes the pose, face, and the hand tracking. Then we have some of the other solutions like the hair segmentation, object detection and tracking, face detection, iris tracking. Like the object detection is like, for example, in TensorFlow.js, we have the Coco SSD model that is used, right? So it's also having a solution for detecting, uniquely detecting different types of objects. And then we also have the 3D object detection, that is essentially the Detectron model. Then we have all like other kinds of solution as well, similar to how the selfie segmentation solution was just released 2 days ago. And if you want to go in ahead and see like the support for all of these different solutions, you can actually just go to the solutions page that I'll just go very quickly. But some of the great features of using MediaPipe is that you do get your ML inference and training, all of that on the hardware as well. So you can use both the CPU, the GPU to further faster train your models. And then you also just have to build one. So you build just one like model, and then it can be actually, that solution can actually be used to deploy it on whether it's like IoT, web, desktop, iOS, Android, mobile-based solutions. And of course, it's free and open source. So you can go and have a look at all these different solutions that we are talking about right now on the GitHub. GitHub.com/Google/MediaPipe. That is the official repository for MediaPipe. Now, if you also look at the solutions, you can over here look at all the different solutions and the support for the various categories of devices. So Android, iOS, C++, like mainly for like, let's say, desktop, Python, and let's say JavaScript, right? So you can also go to the homepage for the docs. Like, these are essentially the docs, and you can see all the different popular solutions that are currently being offered. And if you also want to go deeper into how exactly does MediaPipe work, you can definitely check out the framework concepts. This is a must to understand how does MediaPipe actually run and work. If you really want to go deep into MediaPipe, I would definitely recommend checking this doc out, and that will give you an insight on how MediaPipe works internally. Now, without wasting a lot of time, we'll talk about the MediaPipe Selfie Segmentation Solution. This is the latest solution that has been, offered by the MediaPipe team. And again, it's really, interesting for me because like a direct implementation of this is being used in Google Meet, about which we'll be talking about in a bit. But essentially, if we want to define how segmentation works, so segmentation is a technique in machine learning that helps to identify objects in the foreground, and it sort of takes that whatever it detects, right? It is able to actually sort of transition it out, or like, let's say, uniquely identify it out from the background. So you can consider the segmented object to be the foreground, and then whatever is there outside of it is the background. So how segmentation works then is that it sort of creates like this segmentation mask on the object that it is tracking. And once it is able to track or detect the object, it creates that segmentation mask to uniquely identify and create a wrapper around that object. And now you can do a lot of different effects on that, because you have uniquely identified that object, and you can, like, let's say, change the background. You can add effects to the object, right? So similarly, the MediaPipe Selfie Segmentation solution is basically segmenting the prominent humans that are coming inside of the scene. So we already have like a very popular segmentation model already in TensorFlow.js that has the ability to actually segment multiple human beings in real time and uniquely identify all of them. And similarly, the MediaPipe Selfie Segmentation also works in that way, where it can uniquely identify these humans inside of this whatever scene that we have, right? And that can be used to actually do a lot of different things, like, let's say, add selfie effects, add being able to change background in a video conferencing application. So you can think about a lot of different unique solutions, creative solutions, by using this selfie segmentation solution. Now, if we talk more about what's going on under the hood, and that is specifically talking about the model. So there are essentially two different types of models, the general model and the landscape model. Now, both of these models are based on the MobileNet v3 model. Now, this is a very popular machine learning model that is being used to do things like object tracking detection, and it's already very popular in Python and JavaScript as well. So a lot of different TensorFlow.js based models are also based on the MobileNet v3. And essentially what both of these models, the general and the landscape model, are very similar to each other, but the main difference between them is the input size that we take for the tensors. Now, if you're not aware what exactly are tensors are essentially these multi-dimensional, or like, let's say, n-dimensional arrays that contain algebraic values. So you can consider, like, let's say, a grid of values that have these numerical values, and then of course we do a lot of different transformations and calculations based on these values, right? So essentially these tensors are what are containing the information about the input, right? So whatever input image that you have, it then goes into this input tensor. That is, if we talk about the general model, it's like a 256 by 256 by 3 tensor that sort of defines the dimensions of the tensor, and the output that we get is the 256 by 256 by 1 tensor. That basically is the segmentation mask output that we get. And similarly, in a landscape model, we have a 144 by 256 by 3 tensor. So as you can see, like in the landscape, it is actually a smaller input size, so that actually makes the model also faster and also lighter weight as compared to the general tensor. So in case you are interested, like based on, let's say, the device capabilities, you can choose between the general model or the landscape model. And essentially what's happening is that when the segmentation is actually happening, whatever size of the input that you have, right, for whatever the scene is, it actually automatically gets resized to the input image size, so that it follows the input size dimensions that are required. And then that is, transformation takes place, and only then it is actually fed into the machine learning model. And one of the most interesting things to actually look at is that the general model is powering the ML kit, and a variant of the landscape model is also being used to power Google Meet, and that is something that is very exciting. And if you want to go and look at how it is actually powering that, you can refer to this AI blog that I'll be referring into the YouTube documentation on the description. And this sort of rundowns how the MobileNet v3 model and like the variant of the landscape model is actually being used to power Google Meet, and like the background changing capability in Google Meet that everyone loves, right? And so essentially it's being run on the web, and it's being run using WebGL. It's being powered using WebGL. And you can, if you want to refer to how the pipeline works, and like if you want to go deeper into how the model has been structured, the MobileNet v3 model has been structured, you can look at that. And like, again, this is a really great blog if you want to read deeper into how it's being used inside of Google Meet. I'll definitely recommend that. Now, if you talk about the machine learning pipeline that is being used inside of the selfie segmentation model. Now, again, it's very important to do know about important concepts like graphs, calculators, packets that are inside of MediaPipe. So I'll definitely recommend going and looking at the documentation for that we had covered briefly in the early part of the video. So just to give a very quick overview of what exactly are graphs. So graphs, similarly to how we have graphs data structure in data structural algorithms, and we have the edges and vertices. Essentially, we have these packets inside of MediaPipe that contain the information about the landmarks and the tracking, and these packets are being flown between, like, say, from the input to different types of the within the machine learning model. And essentially these graphs showcase the path that these packets can actually follow from one node to another. Now these nodes are having configurations that define how these packets function and how the calculations on these packets actually happen. So we basically call them as calculators, and these calculators describe how the transformations and how the calculations will actually go on these nodes. So graphs are essentially talking about the paths that these packets follow inside of the model. And now, if you just, we can quickly just go over and have a look at the graph definition that has been defined. So usually the graphs are defined with this file ending, that is the pb.txt file. So essentially, like, it's a text file that defines the node. So you can over here look at the node structure of how the node is defined. And since at the node we also define the calculator, so this shows which particular calculator is being used, and then what's the input stream and what's the desired output stream, right, whether it's based on the CPU or the GPU. So this sort of shows the different types of nodes and different subgraphs that perform the different actions. So whether it's like performing the actual selfie segmentation, or let's say with a particular color, this defines the configuration of how it's supposed to actually happen. And similarly, you can also look at the subgraph definition as well. That's also, again, completely open sourced by the MediaPipe team. And if now you want to go deeper into let's say the solutions API, so basically this sort of tells you what kind of configurations that you can make. So of course the first one is the model selection, because I said that we have two different types of models. One is the landscape, and the other one is the general. So in case you choose 0, you're referring to the general model. If you're using 1, it's the landscape model. Then what's like the output that you receive? So of course the output that you receive is the output segmentation mask, that is covering the object that you're, or like the part of the scene that you're actually segmenting, in this case the human, and it will be of the same dimension as that of the input image. So the input image, like let's say if it's 256 by 256 image, it will be of the same dimension. And now you can also refer to the Python solution API of how to use the selfie segmentation solution within Python by installing the necessary MediaPipe Python package using like pip install MediaPipe. And as you can see, like, we are importing that package over here, import MediaPipe as NP, and then we are also importing OpenCV. Over here, you can look at how like there are different functions that are like sort of telling you how you can draw the selfie segmentation. You take the webcam input that is then used to get the canvas, or like let's say the input that we get from OpenCV. That input is transformed into the desired tensor value, and then that is what is being fed into the machine learning model. And then we are defining the selfie segmentation. And you can also have a look at the JavaScript solution API that you have to either use like let's say the CDN, or you can also look at the npm packages for the model selection. And again, this solution like that we see example that we see over here is using the canvas, so HTML canvas, and then you take your webcam input, and you can use the webcam input, change its dimensions, again use the machine learning model, get the inference out, and show that actually on, and transform the canvas accordingly. So you can have a look at that JavaScript based API as well. So of course there are a lot of different example applications that have been provided, and you have the instructions to actually how to use it on Android, iOS, desktop, how to build MediaPipe examples. And this shows you what kind of graph you have to actually run, whether you want to run, like let's say if it's on desktop, whether you want to run it on CPU or on GPU. And you can have also look at all these different resources. Now I would like to also give you like a web demo. So for that I will just change my camera. So let me change my webcam so that I can, use my primary one so let me actually go to properties and like, give me 1 second. I'll quickly just change it to my other camera. So yeah, I think I've changed it to the other camera. So let me use this and let me save this. All right, so you might not be probably able to see me. There's me. Hi, and I'm going to be now running this web demo. And this demo has been provided by the MediaPipe team. And again, it's a really wonderful demo to understand how it does actually function. So as you can see, like it's loading right now. It's a code pen link, and you can refer to this, to the JavaScript code, and we'll just briefly talk about how it's being used in the JavaScript code. Now it's just loading, and it should be ready in any second now. So let's see. I hope it does run through for us. All right, so that there is right. Of course, like it has super zoomed in my face, but as you can see that the entire background is actually blue in color. If I bring my hand over here, as you can see, like it is able to identify my hand, and it does not color that. But essentially, what's happening is that since it's running on human bodies, it is automatically able to segment out my body, right? And the entire rest of the background is actually blue in color. So this has been actually coded with inside of the model that inside of the code that you have to fill the rest of the background with blue in color. If we go towards the top right corner where you can see the FPS, live FPS of the performance, right, that how frames is happening, you can see over here that you can actually select the different type of model. So by default, it's the landscape model, that is the lighter model. I can change it to the general model, and you'll not see a lot of difference, probably a few frame drops, and I think it just hung for me. Yeah, it actually hung for a bit. I'll change it back to the landscape model, which is of course the lighter one. And you can actually now see that what it actually looks like when we actually have put the effect, and how does it actually look like if you have put no effect. So as you can see that, this is what the segmentation masks look like. So this green color is sort of showing you the segmentation mask. And as you can see, like it can identify my hands as well, my face as well, and my entire body. So like the effect that we have put, like we have used the JavaScript code that has put this effect of changing my background of this blue in color. Now if we quickly look at the code over here, we have defined the container like this simple HTML. We use like this loading to actually wait for the machine learning model to actually load, because that is how it actually works in JavaScript or any web-based application, that you have to wait for the model to actually load, and then you can start using it. So we have basically used the spinner to sort of show it how it's being loading. And like this is defining the CSS, but for us the main concern is to understand the JavaScript code. So the first 4 elements are all about the canvas elements, right? It's sort of defining how exactly is the canvas actually taking place, defining the input frames that we get from our webcam. Then we have like the FPS controller that shows you the live performance of how the model is performing. Then we're using like the query selector dot loading to wait for the model to actually load. Now the thing to we can all these lines from lines number 26 to 32, just showing you the canvas element and how it's working. Now this is where we're now looking at the canvas and how like the masking effect. So basically if it is the masking effect, that is when we are creating a segmentation mask, it is filling in the style with this color. So let's say if I actually change this color to let's say white. So like let's try to run this. So I'll use like FFF, or like let's say black, right? Like let's represent it with black. So that would be 0 0 0 0 0 0, and let's actually wait for it to run. So this particular code, canvas.global composite, and if active effect is mask, that means if you're just using the masking effect, that is the segmentation mask. Now like since I've changed the color, it should only be black, I guess. Yeah, there you go, right? And similarly, we should also have a function where it's looking at the background. So if I again change the style to, let's say over here, I can change it to white. So it will basically create like a white background. So let's do it FFF, that's 6F. All right, so I think now it will just show you a white background. So how this is how, like, we are using JavaScript to actually change the canvas fill style. That is changing, the style element of the background. So now I should essentially see a white background, as you can see very clearly. And over here we have now, used the camera, and we have sort of used an async function that, so how async functions work in JavaScript is that it actually waits for something to happen, and only then it will work. So if it receives a response, only then it actually, executes this function. So we use this only after the model has successfully been loaded, and this sort of defines the control panel that, allows you to select all the different things that we have over here. So that's essentially the output, and like that sort of, comes to a close on what exactly is, the selfie segmentation model is all about. In case you have any other questions related to the selfie segmentation model, feel free to, drop in a comment, or you can reach out to me on my social handles that I'll be, also providing in the YouTube description. So in case you want any help regarding MediaPipe, or with, the selfie segmentation model, I'll be more than happy to actually help you out. Also, I'm currently a Google Source Code mentor at MediaPipe, helping build the Unity plugin for MediaPipe. So definitely do also check out for that in the coming future, where I'll be helping my mentee Pulkit Midha in actually building the Unity plugin for MediaPipe. Again, thank you so much for tuning into this live stream. I hope that you liked it, and please do share it if you want, and do subscribe if you want to see such kind of more videos. Thank you so much for watching, and I hope to see you in my